Thank you, Dr. Lianage. I think it's not a brief introduction, it's too much of an introduction. So, thank you very much, IIT, for inviting me for this particular webinar. And actually, I can remember Dr. Lianage was trying his level best, putting his highest effort to find me, catch me for this. Thank you very much for that. Today, the subject is very clear and it's a very timely requirement of the country. We are trying to develop the country in a sustainable manner. That's what we say. Let's try to understand whether we are trying to do that on the correct path and whether up to which level we've been successful on that path. As the title said, this emerging and sustainable technologies, let's try to understand what these emerging and sustainable technologies are. I'm not trying to teach you anything on that subject. We have a very interesting, eminent audience here. I can see a couple of my friends, and it's very easy for me to take this title forward because most of the members in the audience are number one, known people, as well as the people who knows about this subject equally and better than me at points. Now, the rapid development part is required as a country. Engineering is the key, and unfortunately, development engineering is the missing point according to my thinking in this country. We are in a couple of silos. We are trying to develop things in a couple of silos. Engineers are doing their job. Scientists are doing their job. Academicians and academics are doing their jobs. There's a huge problem in bridging these dotted lines between scientists, basically starting from academics to scientists to engineers and engineers to the marketeers. This is the missing part here. Let's start from there. So the biggest problem we are facing now in Sri Lankan perspective is to understand the lacking points and to understand the ways of bridging these gaps. When it comes to development or development projects or R&D projects into sustainably developed research projects or development projects, there's a huge life cycle with multiple levels in it. We start with hypothesis, just like a general science research. We already got a lot of hypotheses. First of all, we dream about a project, we dream about a new science, then we come up with hypothesis, then we do a little bit of literature survey. I'm just trying to revive your ancient memories. So then we go into prototypes to development prototypes, pilot programs, then manufacturing, then marketing, then basically earning money. But there are huge gaps in this particular life cycle. So we dream. Now, dreamers are also missing in our system. So when we were schooling, when I was starting my innovation career, when I was in grade 8, when I was winning the IESL Junior Inventor of the Year title in 1989, we were dreaming. I didn't know anything about chemistry at that time. I was in grade 8. Developed something to the country. Those days, there's a huge problem. I'll just touch upon the starting point. That was my starting point. My family background is full of engineers, so I got that leaked into my head as well. But when it comes to that era, 1988, 89 era, there's a huge problem. The fishermen started, they were putting formalin into fish. So there was a huge ha-ho that formalin is in fish. I wanted to develop something with the electronics knowledge I had. I had a very simple electronic knowledge because I was, surrounded by electronics engineers in the family. So put my fingers into that, develop something, a tiny little thing, but I won the national title with that. Then famous Professor 𝐶𝐾𝐦𝐿 came to me and said actually Professor 𝐶𝐾𝐦𝐿 and Dr. Ravijayawardena was chairing the interview panel. They came and said, you should stop your innovation now. You should focus on your education, stop all the electronics and go ahead with the education. But I didn't do that. I was continuously dreaming and trying to put things together and trying to get some things out. So ended up here. But when we look back and look forward, there's a huge gap. The gap is scientists are completely clueless about the engineering aspects. Engineers are well aware about some sciences, but not 100%. So how to bridge this gap? I can see �គ𝐦𝐿𝐽𝐿, my friend, my colleague is in the audience. He's one of the best persons, to discuss about this, because he's one of the research scientists, being an engineer, research scientist in SLINTEC. So the gap is that our scientists can dream about new things. They can come up with very interesting new ideas. But when it comes to the engineering aspect of it, there's a huge lacking area. Let's try to understand what sustainability in technology, science, and engineering is. I'll try to take some practical examples and very successful examples we were ended up with. First of all, the resources are the main problem. It's not a problem. Understanding our resources are the main problem. We have, when it comes to engineering development or scientific development, the biggest requirement or biggest resource here in this country is our natural raw materials. Parallelly, our local expertise. These two are very important to any development project, especially when it comes to a sustainable development. If it is not sustainable development, it is basically development. The second one, the expertise, should come first. But here, since we are talking about sustainable development, local raw material, locally available resources will play a huge role. Then we have the human resource aspect of it. We are unparalleled to anyone on earth because we have been working with various countries, various institutes, large institutes, but our HR basket, or our human resource database, is huge and much valuable than most of the other human resources baskets out there in the world, because our knowledge is multidisciplinary. If you take a mechanical engineer, most of the mechanical engineers in Sri Lanka can simply handle electronics, mechatronics, automation, basically the entire spectrum. But if you go talk to someone in Siemens, if he's a mechanical engineer, he will only perform mechanical engineering and only mechanical engineering. So our multidisciplinary knowledge base is very important for us to come up with faster developments with a small pool of human resources. Then there's another important part here in Sri Lanka. The ancient knowledge we've gathered in most of the documents. You have not familiar in this aspect of it, definitely. So when you go back to our ancient documentation, especially the document cluster called Attakatha, if you start reading Attakatha, people, you might think that Attakatha is something to do with the religion. No, Attakatha is basically a handbook. In Attakatha, you have various types of engineering, various types of sciences they have practiced in our ancestors. The small tips and support paragraphs are there in order to get things done in the day-to-day life. So especially when it comes to the latter part of Attakatha, it's just like an encyclopedia of engineering practices, scientific practices, especially Ayurvedic practices. We're not going to talk much about it, but since you get to know about it, try to explore Attakatha. Then as engineers, you can see a lot of relevance between whatever you do currently and in these ancient handbooks called Attakatha. So with everything, where are we now? So just to talk about that part, where are we now, I'll take two major successful projects where I was a part of the project from the beginning. So I'm trying to talk about graphene story from graphite. Most of you all know about the Sri Lankan graphite. We have the best vein graphite mine in the world. We are the only vein graphite mining country in the world now in the current situation. There are other countries who mine graphite. Most of the Eastern European countries, China, Russia, they have only flake graphite. But this vein graphite is very, very important as an engineering material, extremely important as an engineering material in most of the engineering developments, like in tribology, in lubricants, especially when it comes to conductors, especially when it comes to energy storage materials and charge acceptors, charge accepting materials, to go into batteries, to go into supercaps, to go into lubricant additives, and in the other aspect, now into solar panels, and very important, timely important energy and energy related aspects. That is one part of it. Then graphite being used in different applications. 60, 70 years ago, Sri Lanka was the graphite country in the world. We used to have 3,000 plus mines. Now we have only 3 mines up and running. And we used to develop thousands of metric tons of graphite according to the export manifests and export documentation. But now currently we do only 300 to 325, maximum 360 tons a month. Good that we do that, because we don't add value. Graphite, we simply export as graphite. We have no value additions today in Sri Lanka. It's a crime, but what we are trying to change is that. Then when it comes to other applications of graphite, you have crucibles, you have high temperature devices, then that part of it. Then graphite goes into intermediates, expanded graphite, then goes into the ultimate value addition, graphene oxide, graphene platelets, and pure graphene. Then the second subject I'm going to talk about is plastic to fuel. I mean, it's a common subject for most of the people, but we have secured 2 IPs and we found a very unique method, a continuous flow method, and a very important method to convert plastic into fuel without any catalysis. We don't use any catalysts. Without catalysts, we managed to eliminate the wax problem, which is the problem in the world with almost all the companies who attempt to do plastic to fuel conversion. Let's start from there. So we are trying to discuss about current status of these 2 projects, and actually 3 projects, which is not, 1 project is not listed here. Then current status of the market in Sri Lanka, negligibly small, but out there in the world, and knowledge contribution from the industry to the academia, to the STEM education, to the general public, and knowledge creation, the new knowledge creation. We simply attracted reasonable amount of PhDs, our own PhDs from outside to Sri Lanka by recruiting them into these projects, especially in Sri Lanka Institute of Nanotechnology. Then number 5 is protection and preservation of our knowledge, number 1. Protection and preservation of our raw materials and our natural mineral resources is number 2. So when it comes to graphite, it's towards the highest possible value addition, graphene. Let me introduce about graphene a bit within 1 minute. Graphene research was started officially by 3 British scientists from Surrey, and in 2004 they invented graphene in 2004, and they won the Nobel Prize in 2010 for graphene. Simply single layer of graphite or single layer of carbon. Ultra simple material, but ultra complex, extremely complex characteristics and extremely valuable characteristics. When it comes to emerging technologies, when nanotechnology came into the picture, we were thinking that nanotechnology is the game changer on Earth. Nano can change the entire humanity, human engineering, engineering to science, science to medical. We were under the impression that this is the savior. Then, as a derivative of nanotechnology, graphene and carbonaceous material in the nanoscale came into the picture and started playing a different role within the nanotechnology sphere, showing us a completely different capability set of engineering, material developments, and especially when it comes to NEMS and MEMS, real nano and micro scale devices. We were under the impression that nanotechnology is going to change everything, but after a couple of years, after graphene came into the picture, it was little diverted and dramatically changed. So we started a company. What has happened was, in Sri Lanka Institute of Nanotechnology, a couple of scientists, a couple of actually senior scientists started this program very parallel to the Nobel Prize. In 2010-11, a couple of professors, including Professor Gamini and Dr. Dilushan Jayasundara, those are simple names, but one group of people started working on a new technique to convert Sri Lankan graphite into graphene. So I'll go here first. Then they found a new technique, which is comparatively a greener technique to the, at that time, there was a technique called Bode's technique, as well as, actually there were a couple of techniques to convert graphite into graphene. Hammers and modified hammers was leading. Then our people, the people who developed this, started working from modified hammers to a new greener technology, and we found a new technique to convert graphite into graphene. Purely science I'm talking about, not engineering yet, and they got this patent. We got the patent in 2019. We filed the patent in 2016. Then we started working on this new technique. We started converting ample amount of graphite into different types of graphene oxide, then graphene. So in 2018, once we have realized this, we in the sense SLINTEC, I was a part of SLINTEC. Now, since I'm wearing multiples of hats, sometimes this we and I will mix up things. So at that case, we SLINTEC came up with this unique process. Process was perfectly working, characterized properly, and we were matching our graphene quality with the graphene giants, the giants of graphene in outside Sri Lanka. We compared our capability, we compared our characteristics and data, and we have realized that our data and our characteristics are much better than all the internationally acclaimed large players like Graphenia to 3K Graphene to almost everyone. What's the secret? Yes, the science played up to a certain level, but the secret was our pure vein graphite. Unique morphology, unique crystallinity, unique electrical conductivity, unique exfoliation energies, very, very unique exfoliation energies and bonding energies. We were unique in our material. Then we had enough mines to get graphene or graphite to produce graphene. We were happy with the numbers, we were happy with the quality. So we have 3 running mines now in Sri Lanka, Bogala, Kahatagaha, Ragedara. There are 2 other small mines. We have our own mine. Kahatagaha, we've been working with Kahatagaha and Bogala. So private sector organization, as private sector organizations, Bogala started giving us a super support. As a government organization, Kahatagaha Graphite started giving us a very good support. We started converting Bogala Kahatagaha graphite into graphene with this unique process, high quality graphite, and we became sustainable up to a certain level. Why I'm using the word up to a certain level, almost all the other chemicals has been imported. Sulfuric acid to potassium permanganate to H2O2, you name it, everything have been imported. Only the major raw material and the heart of the entire project was it's a sustainable resource in the country. And thankful to the scientists who developed this technique, we are comparatively much more eco-friendly than all the other techniques used by the other people. So this is the unique proposition we had. And we started Ceylon Graphene Technologies by investing $2 million. It was for a general engineering project. That was a huge amount of money, but thankful to some of Sri Lanka's enterprises, within a day, I was in a position to attract this $2 million and they've invested. I'll tell you who these companies are and where these companies currently are. This is the importance and the uniqueness. Again, we are the highest mined graphite quality in the world. We have a patented technology. We have our own scaled up manufacturing process, and we have a dedicated laboratory for research, innovation, and product development. That is where the real engineering comes into the picture. Yeah, of course, there's engineering input. There's a serious engineering input to manufacturing, but much more than that, we need super engineering inputs to develop products with graphene. That is where the real selling point is. So this is our dedicated research laboratory and the team. Don't worry reading all these lists of equipments we have. We are categorized as one of the Southeast Asia's best characterization laboratory in the sphere of nanotechnology, which is located in Homagama. We had almost 60 to 65 scientists. Now we have 45 scientists. Due to COVID, due to various policy-related problems in the country, most of our good scientists left SLINTEC as a research organization. Let's talk about it in our final slides, but this is our laboratory. And now we have a plant which can produce 4 metric tons of RGO per year, generally 800,000 liters of RGO. It's a very, very light material, extremely, extremely light material. So 1 kilogram is around 202 to 205 liters. And it's 100% local engineering exercise, 100% local science exercise. Engineering, science, and fabrication of the plant is 100% local. And again, it's a proud IP ownership of Sri Lanka. And as a simple example, there are a couple of companies from various parts of the world came to SLINTEC to buy over the IP, just to get the IP for themselves at a very high price. And we said no. We said no, and we started producing on our own. Currently, we have this facility. This facility can produce 4 metric tons to 4.5 metric tons of RGO and nearly 8 metric tons of graphene oxide per year. I'm not going to talk about the process engineering or chemical engineering aspects of this plant, but when it comes to the real process flow, I'll just give a simple introduction. We get graphite, and it's a huge exfoliation process. We are using nastiest, most chemicals known to man to do that. We are using conch sulfuric to conch HCl to H2O2 to potassium permanganate to do, you name the oxidizers, you know, we are using them because this material is hard. This material is very strong and stable. Now, graphene is multiple. So the graphene is single layers of graphite. Graphite is multiple layers of graphene. So now we are exfoliating. We are taking one layer by one layer. Then only we can call it graphene. That is where the real price tag is. And to exfoliate, to detach and exfoliate, you need this oxidation process. So if I tell you the most challenging part of the entire product development and the entire process development is the waste handling and waste remediation. When we are using 18M H2SO4, when we are using 35% H2O2 and potassium permanganate, the entire waste material is full of that. Right? Central Environment Agency is behind us always. So we have developed the engineering marvel again to convert this waste material into usable materials. After we produce graphene, parallelly, we currently produce 2 agriculture products from the waste material. That is how actually I want to link graphene production and Eppawela rock phosphate together. Let's talk about it in few minutes. This is our plant, and other than graphene, we've been developing a couple of other materials, and we have a full-scale electronics laboratory to characterize and measure the capabilities. And this is this particular product I'm showing you is the only product in the world in this size and this conductivity. This is called super expanded graphite. Us in SLINTEC, as well as National Institute of Fundamental Studies, NIFS Hantana, developed this parallelly, and we work together to get into this success. So these worms can be only manufactured with Bogalle graphite particles, not even with 𝐶𝐜𝐻. But when you see the characteristics of these materials, it's super characteristics. We are talking about micron level 4 probe readings, and we are talking about room temperature magnetic levitation properties. Once we squeeze it with small 4 neodymium magnets, it starts levitating. You can understand the conductivity and the higher conductivity capabilities of this material in order to get the magnetic levitation properties. In the room temperature. Then there is again a real engineering and science challenge. We differentiated the characteristics because if you can remember, I was talking about Bogalle here. Bogalle is the only I wanted to understand as scientists, what are these differences? Why Bogalle, 𝐶𝐻, and Bragedara are different to each other? So we have done that for the first time in our history. So we somehow got extremely valuable set of data still in the science spectrum, not in the engineering spectrum. With this data, we started converting this knowledge into product development. Now we are trying to react engineer's role in this. It's an unfortunate situation. I'll talk about this unfortunate situation in latter part of the presentation also, but the unfortunate situation is most of our scientists are clueless about engineering. Actually that is unacceptable up to a level. I'll tell you the reason. Now, most of the scientists we get is chemists, started with biology stream. They started their career with the biology stream in advanced level. Their mathematics and mathematical thinking capabilities are comparatively, I'm not telling you all that it's zero, or I'm not going to undermine them, but comparatively lesser than the scientists we get from engineering streams. So most of the chemists are coming from the non-engineering biological backgrounds. They perform very well, but when it comes to real conversion part of it, they are extremely good at laboratory level experiments. They are extremely good at data collections. They are extremely good at, especially if you are coming from Peradeniya, they are extremely good at statistical data analysis. Don't get angry with me, the other people, because these are the experiences I'm sharing with you, working with these people from the last 22, 23 years. When it comes to Peradeniya people, they are analytical, no, not analytical, they are statistical data handling and statistical decision-making knowledge, and the capabilities are comparatively higher than all the other universities. There are reasons for that, but that's what we get. When it comes to science, almost all the universities are perfectly doing well, but when it comes to science towards technology and science towards engineering, there's a huge part lacking. So if I introduce you, if I just take you through the product development pathway at SLINTEC or in my laboratories, we take engineering challenges, or we take product development challenges, or we take challenges from the industry. So the industry owner or industrialist works inside SLINTEC with their problems. Most of their problems are chemistry, physics, and little bit of, on the base, I'm talking about, little bit of physics related, right? So the most 95% of their problems are chemistry related problems. That's why they come to SLINTEC, or they go to ITI with food science or natural products or natural product development, they go to ITI. If it is a problem with their chemistry, material development, or chemistry towards product development, they come to us. When we talk to them, they tell us their problems, and we pass their problems into our scientists. They are very good at their science, but they really can't understand the deliverables of their scientific projects. They do the science. As an example, if you ask them to develop something to use as a toffee, they might end up with a toffee-like thing, which costs you 2,000, 3,000 rupees. Those are my experiences, right? When we want them to develop something to go into a pillow or a shirt or a button in that case, they will come up with a fantastic product working perfectly, but your button, the selling price of your button might be in the range of 600-700 rupees because of the material cost or the approach. Since they don't take the engineering approach or the mathematical or the analytical approach in that aspect, I'm not talking about the analytical chemistry part of it, I'm talking about the analytical product development, lacking in that aspect, and they are basically not thinking about that. In SLINTEC, we have very few engineers, dedicated engineers, but we have very good engineering backgrounded scientists. We have somehow headhunted and got these people, but in a general case, this missing element is playing a huge role in failures. Failures of projects, failures of marketing of the product, and so on and so forth. This is the most important and missing link in all our projects. Right? If we are in a position to inculcate engineering knowledge, or if you are in a position to come and work with scientists as engineers, from the day one, if our scientists can wear a semi-hat of engineering, the product development speed will be faster. End of the research program, we don't have to go here and there for secondary problem solving. How to do it, how to convert it, what to do with this can be resolved during the journey, not at the end of the journey. Now the problem is, they come up with super fantastic beak and test tube results, but no one knows how to come up with a chemical engineering process or a process engineering process or a automation process to get it done in order to produce it to sell or produce it to offer to the end user. That's the biggest problem we are facing. Okay. Before we go to the other project, now as engineers, I'm sure we have a couple of scientists also in the audience. As engineers, if you are in a position to understand these materials and the capabilities of these materials, the behaviors, characteristics of these materials we develop in the scientific arena, then you might think of completely different applications of these materials in your respective areas. Imagine if we have a engineer in this audience adding little bit of graphene oxide into rubber, into natural rubber or synthetic rubber, can alter and change very important characteristics of rubber at a very low cost. most of our scientists knows how to develop this material, but they really can't understand, or their domain knowledge in rubber is minimal. Then their domain knowledge in conversion is near zero. Right? I'm not talking about SLINTEC scientists, because after working 10 years, 12 years, they are well conversant in these subjects now. I'm talking about scientists in general. Their knowledge, the scientists' knowledge in real product development and deliverable part of it is lacking. If you as engineers can get together with scientists from the beginning of the project and try to guide them towards the last point, the plant, which can convert their science into usable, sellable engineering products, that is where the secret and the key is. That is where the real success point is. That is where the real money-making part of the entire project comes into the picture. Now, I was serving as a senior scientist, as a head of business development, as a director, as basically almost every level in SLINTEC. I used to go talk to people. I used to go talk to the industry, telling them that, okay, if you invest a little bit of money in SLINTEC, we can convert your this into that. Or we can produce something very new in order to give a unique selling point into your product range, and you are going to be the number one in the world. Those kind of stories I used to go and tell people. Those kind of stories are practical, viable stories. But most of the cases, it is not going up to that level due to this gaps between dots. First 10 million in SLINTEC to convert this in a unique data set where you can apply into your this product, and the USP in that particular product will take you into the pioneering position in your respective domain. It's a very simple story we used to go and tell. And they come behind us. Then they pay money, we do research, and we come up with a fantastic prototype. Almost every time, my scientists, they come up with perfect prototypes. But when it comes to real applicability in the industry, for industrialists to use it to convert and earn money, then the problem starts. You should play that role as process and chemical engineers, number one, mechanical, automation, mechatronics, number two, electrical electronics, not a big deal. You can simply do something with it. Most mechatronics people can do the required electronics now, and we don't do high voltage and related work. So when it comes to our work, it is mostly plant design, process engineering, chemical engineering, then pilot plant fabrication, and you need reasonable amount of common sense, where unfortunately general science people doesn't have, only engineers got. Right? And these people will kill me at one point if they listen to this, but that is the truth. Engineers are always good with their 2 cents and their common sense. That's where the reality is. So, having said that, we'll go into the other project. So after this problem started with
Manju, let me disturb you for a minute. Small notice for the participants. Those who join after my first introduction, the chat box is open for your questions. So at the end of the session, we will take up your questions from the chat box. So please raise your questions in the chat box. Thank you, Manju. Going well.
Sure. Thank you, sir. So after this incident happened, I mean, this is the first time you are seeing something like this of me, Totamulla. Dr. Lianeke was talking about my drone operations. This is the first proper drone 3D operation happened in the country with proper set of drones. And we, after the collision of this, after the breakage of this 𝐶𝐬𝐿, within 4.5 hours, we modeled the entire 𝐶𝐬𝐿, and we have realized that it is not an avalanche. I'll touch upon that because most of you all were under the impression that this the garbage pile broken and simply avalanched on houses. No, it's not. You can see the breakage area is the dark area, and you can see the houses are way, the distance is somewhere around 45 meters to 50 meters between the breakage point and the nearest house. This garbage did not come on houses. It was not a garbage avalanche and people didn't go underneath of the garbage avalanche. That was the perception and the news given by the media. This is a unique scenario called deep-seated slope failures. Civil engineers know much better than me. My civil engineering knowledge is sub-zero, but with the support of University of Moratuwa, they have realized with our data sets and the contours, they've realized this is not an avalanche of garbage. It's a deep-seated slope failure because this entire garbage pile is floating. It's on a paddy field. It's a huge floating garbage pile. So the top level broken and fallen onto the other level or the middle level, and with that pressure, the toe of the garbage pile started going up. Then houses elevated. Basically, they rise and went and basically settled on other houses. Garbage did not come on these people's heads or on houses. So having said that, after this, we wanted to start this project to convert non-segregated, non-reusable or reusable plastics into liquid. Simple technology. Most of the people in India, everywhere, China, they've been doing it. We wanted to do it in a different way. My partner, Mr. Ananda Hettiarachchi, most of you all know about his background. He was one of the founder members and a managing director of 𝐶𝐬𝐿, super, according to my classification, super chemical engineer. So he and another young scientist with a super engineering and thinking power, a person who won the Kotiyak Patina Adahasak of Sirsa TV. I realized the person as not as a scientist, but as a versatile character. We recruited him and he came up with this idea. He came up with this idea to convert this into super diesel and ultra purified diesel, but we stopped halfway. We wanted to develop something unique and to get the IP. So everywhere in the world, when it comes to this particular wax, because they are producing waxes. In this subject, I'm not going to talk about each and every engineering and science part of it because we have 2 ongoing IP filings and some areas are still not classified but not protected by IPs. So I might not go into depths, but you can ask questions. If I'm not in a position to answer everything, I will definitely invite you to our facility and basically demonstrate and we can talk about it. For me, engineering or science or whatever the knowledge has to be open. We are talking about open innovation. Why we go for patent is basically on the commercial requirements of investors, not because of we really want to share everything with everyone. But when it comes to these investors, they want to safeguard their investment as well as the IP for them. So unfortunate, but can't help. Professor Ajit Dialvis from Moratuwa is the person who taught me this years ago. Open innovation, we are open. We simply share whatever the knowledge we have with anyone. So in this case, we wanted, everyone was, 99% of the industrial operators are doing batch processes, general incineration, general thermal processes, and incineration in with thermal control. It is flame as well as electrical heating. That is where this waxless conversion came into the picture, and it was a success. So we maintain precision temperature control here. That is how we ended up with this yellow color, golden color oil all the time. Generally, when it comes to pyrolysis oil, you have experienced those are tar-like, blackish, full of odor, some useless liquid. When it comes to it's a very useful liquid when it comes to calorific energy, but it's a very nasty liquid when it comes to handling. Especially when it comes to secondary usage, people face hell by using them. Wax formation, then their cleaning, then their odor control. But here, we ended up with this golden color. Most of the times we are much clearer and beautiful than diesel with this new technique. So we came up with this small reactor first in our Sapughaskanda facility. You can see the clarity. This is with single physical filtration. No catalyst used, no catalytic reactions, no catalytic breakages, nothing. This is a simple thermal manipulation, and we are getting this out. So this particular unit can produce 200 to 250. This particular unit can handle 200 to 250 kilograms of plastics a day as a pilot and a proof of concept. With these 100% automated and with a very precise SCADA, we collect almost all the process variables, and we have mathematically modeled the entire baking process. Then we managed to get 82%, the remarkable yield of 80 to 82%. So when you put 1 metric tons of waste plastic, we get 1,000 liters of sellable fuel. 1,000 kilograms to 1,000 liters due to the density variation. It's 1,000 to 1,000. We call it 1,000 to 1,000. And no wax handling. It's just a matter of bottom mud or a reactor bottom collections, because when it comes to plastic, we put various types of additives and fillers into plastics. Now we put calcium carbonate, we put precipitated nanoparticles of calcium carbonate, we put talc, we put various different types of fillers. Those fillers will remain, and we simply take it out and send it to someone who can fill the land. So this is the plant. Now from this plant, we are in the last stage of 4 tons a day plant, and we just got our lands cleared in Kerala for 50 tons a day plant. So we collected the entire, actually it is 20% science and 80% engineering, because the science is common to anyone, the thermal breakdown of hydrocarbons. But here the thermal breakdowns of hydrocarbons in a mix. Here you have short chains, mediums, long chains. Then you have adhesives. When it comes to different types of plastics and plastic bags, you have laminated plastics. You have metallized polyesters, metallized PPs, metallized part of it. Then we simply don't want to put PVC. Other than PVC, we put everything. And uniquely, we don't have a chimney here. Our exhaust gas is again a syngas for us to run the process itself. And our chimney temperature, or basically the exhaust temperature, exhaust is 0 of hydrocarbons, near 0 of hydrocarbons. And exhaust temperatures are in the range of 40 to 45. We don't pollute, we don't heat pollute the air also. So some scientists or engineers might be having a lot of questions here. I would like to invite them into Sapughaskanda. They can touch, feel, and run the facility and see. No odor at all. We incinerate different types of garbage, plastic garbage, and no emissions. So we are now planning to do a little bit of environmental studies, analytical studies, to collect exhaust air or the air around the plant and to do some GC and see what are the real exhaust materials. So that is where we are. Then it's a process, forget about the process. Then we gave our material to Sri Lanka Petroleum Corporation, and very importantly, you can see the amount of sulfur. Now, obviously, sulfur cannot be in this oil because it is converted polythene into fuel. This 38 milligrams of sulfur is negligible sulfur content when it comes to a heavy, comparatively medium to heavy fuel. Generally, in our furnace oil, you know better than me, we are talking about 5-digit numbers of ppm of sulfur, but here it is always less than 3 digits, so almost 2 digits, and we are in a position to remove this sulfur also, but it's not that necessary to invest that money or to put that money into that. The comparison is with furnace oil. We are 7 to 8% higher calorific energy than the market available furnace oil, and furnace oil is sold at 96 rupees 20 cents, if I'm not mistaken, here in Sri Lanka. We can produce this at a very low price, and we'll be saving a lot of money of the government, and we'll be saving the environment, and very importantly, we'll be simply reducing the piled up plastics, the piled up non-segregated plastics, which is simply 160,000 metric tons in Kerawala after beta-tubular breakage. You have similar amount of non-separated, basically mixed garbage with organics in Blue Mandal. We are now trying to do some hulling and try to get it out. And you have equal amount of plastic piles everywhere in the country, especially in Kurunegala dump site, in Guhagoda dump site in Kandy, and Karadiyana in Borlaskamo. Karadiyana is huge and mostly non-segregated, and Dompe is a technical landfill we have, and now we can slowly take the Dompe plastics into this and give Dompe another life, because Dompe is getting filled up now with plastics, because most of the plastic Dompe, the technical landfill accepts, cannot go anywhere other than Dompe because of the chemical contaminations. Here, we can simply incinerate and get fuel out of that. So this is one of the uniquenesses. And we are near zero sulfur, higher calorific energy, and zero wax formation. It's a new IP. We have filed, actually we are in the process of filing 2 WIPO and PCT patents. So we will be the first to do complete wax elimination during the process. Very importantly, there are wax eliminating technologies with chemical cracking or chemical catalysis. Here, no catalysis, no chemicals, only precise handling of temperature in the incineration system, and the multiple level of material or the temperature handling. So this is another story. Last part of the presentation is simply to bridge a gap between graphene production and Eppawela rock phosphate. I promised to touch Eppawela rock phosphate. Now, I was talking about conch sulfuric as a waste material. So with this conch sulfuric, we use 18M conch sulfuric, and our outlet from the facility is 6M to 8M conch sulfuric, or 6M to 8M sulfuric, and this is sufficient enough for us to dissolve Eppawela rock phosphate, right, in order to recover P2O5, plant available phosphorus. So we are a country, we import almost the entire requirement of phosphorus into Sri Lanka in the form of TSP, triple superphosphate. Actually, it's a crime, because with triple superphosphate, we used to get a lot of heavy metals into the country, because the TSP manufacturing process, they use different qualities of apatite. Most apatites are with a lot of heavy metals, including cadmium. So our apatite reserve, or our apatite mine, is near negligible amount of cadmium and very little amount of arsenic, which is negligible. And there are challenges, yes, let's talk about it. But we are simply putting out 2.5 to 3 metric tons of 6M to 8M sulfuric a day, trying to use another 2 to 3 tons of sodium hydroxide to neutralize it and discharge. That is a normal process in other countries. But here, we basically explored the possibilities of using this sulfuric in ERP dissolving, and it became successful. That's number one. Number two, we have another very important agriculture or fertilizer. I don't use the word fertilizer. It's an important agriculture chemical, potassium sulfate. So part of the sulfuric can go into potassium sulfate production. Potassium sulfate is a very, very important contributor of potassium as well as sulfur. In the paddy system, I don't know whether you all are aware, as scientists or as engineers, we have a huge problem in sulfur. So we have a considerably alarming sulfur deficiency. So we will be supplying sulfur and potassium in one package in potassium K2SO4, potassium sulfate. So we are planning to move into much greener graphene manufacturing facility by using sustainable materials available in the country, which is Eppawela rock phosphate. So these kind of synergies became possible, right? It's kind of synergies became possible because of the unique combination of scientists as well as engineers working together in SLINTEC and in my organization, Sri Lankan Graphene Technologies. In almost all my organizations where I contribute is full of scientists and engineers equally. That's where the secret is. Okay. From there, all these projects are completely developed by Sri Lankan scientists and engineers and 100% locally fabricated. Yes, of course, these reactors, those glass-lined reactors imported, almost other, I mean, I don't have to tell you all the equipment's imported, but fabrication is 100% local. Plant design is totally local. The entire process design and the chemical engineering aspects are 100% local. The entire IPs are 100% Sri Lankan owned. Likewise, we are in a position to add value into most of our materials. I'll simply touch upon, I think I have another 5 minutes, right? If you take monomonolite, MMT, we have a process to convert MMT into nanoclay, a cleaning process. We have protected IP in Sri Lanka Institute of Nanotechnology for that. We have another protected, or the IP belongs to SLINTEC to convert monazite or to extract thorium from monazite, radioactive thorium from monazite. 17 to 18% of thorium is in monazite. We have considerably large deposits of monazite in Sri Lanka. So we found a new method. Our scientists in SLINTEC mastered the technique to extract thorium from monazite. So that's another mineral value addition. Monazite converted into thorium. Thorium is the nuclear program input in Indian system, When US is using uranium, India is using thorium. So we have thorium in it. And in our monazite, we have 1 to 2% of uranium as well. So we are a mineral-rich country. We don't really know what it is and what to do with it. So we have graphite, the most unique graphite in the country. We have thorium. We have natural nano clay MMT monomonolite in the Mana basin, especially around Murunkan. We call it Murunkan clay. And this Murunkan clay purified into nanoparticles or nano clay is a very important material in active filler industry, active filler requirements in packaging industries. Now these materials can go into anodes and cathodes of different energy storage systems as well as into supercaps, and mostly as active fillers in different plastic and packaging systems. And it's a very good oxygen inhibitor or a permeation stopper. Oxygen permeability will be reduced by adding a little bit of MMT into your extrusions, plastic extrusions. So likewise, we are a rich country. We are a rich country with our natural mineral resources, and very importantly with our HR. The missing point we've discussed, and the biggest gaps are, as I just mentioned everywhere in my presentation, engineering knowledge in scientists, bioscience backgrounded chemists. I'm very sorry to tell you this, but this is what we face. And lack of mathematical analysis and the mathematics and the mathematical thinking capabilities of most of our scientists. Basic and not basic, actually it's a wrong word I'm using, I'm very sorry about it, but sufficient chemistry knowledge in chemical engineers. There's another problem like that. If our chemical engineers produced in major 2 universities in Sri Lanka got sufficient amount of chemistry knowledge in order to resolve chemistry problems, not everyone, but at least a group of, let's say, set of chemical engineers, enthusiasts, then the conversion and the quality of conversion and the speed of the conversion will be much favorable to the country. So those are the small missing points, right? I really don't know the amount of credits we teach in 𝐶𝐻 and Peradeniya of chemistry into process engineers and chemical engineers. And if they can start their career with chemistry background, at least as an elective, we can see some better synergies. And bioscience students, yeah, they learn a little bit of essential mathematics, but not to polish up to the level of engineers who became chemists or mathematics students who became chemists. So those are the major problems. If the audience, if you can think of something, I always tell my staff, my colleagues, we should start everything from the heart. Yeah, we are talking about science, we are talking about engineering, but heart plays a very important role here. We start, almost all the projects, personally myself and my team starts, those projects are results of dreaming. We simply dream always about something new, right? About something new. And then if you don't have the knowledge, we can always group up. We have very interesting engineering groups and science groups. Come up with a team. Team can play a better role. Then convert them into prototypes. Prototypes are extremely important to develop prototypes in mind the engineering conversion. Not to develop a prototype as a demonstrating agent for a science exhibition. Having in mind the end of journey conversion to products. Then we always complain that private sector is not helping, government funds are not there, you have no money to develop things, we have no support. Support money, private sector, the government sector will come when we show proper results, right? my experience is for me to attract $2 million for graphene project, it was only one day. I'm not exaggerating, that's the truth. When we deliver something, these investors are not reluctant anymore to invest into any other projects. Then slowly we can teach them that all the projects are not going to end up as a successful project. When we do 10, it's only 2 will go into a market. Those things will be simply slowly taught to these people. Otherwise, they expect everything to be converted tomorrow and go and sell and earn money. But slowly, we can teach them the reality of science, reality of engineering, then we can attract them. Especially when it comes to these post-COVID conditions, there are huge openings in the world. Almost all the big players they got hit. Fill bridges or fill these gaps with our products. So thank you very much. I think actually I was trying to share my experiences and the failures, and that's all I can share with you. Success stories are there. Those success stories are purely because of the dedicated scientists and engineers in our teams. But most of the times, the real success from my side is the fearlessness and working with the heart. We put heart first. That is the word. Simply go and start the game. Then, when you start it with that positive mindset, funding to proper knowledge set to people, everyone will nicely coming to the system. So thank you very much, Dr. Lalit. I think we can take some questions, maybe a lot of questions. I saw some questions popped up. So thank you very much.